How many people are planning to install VisIT and follow along?
Oh, sure. Why not?
Okay. So I have two sites open here. So I googled VisIT downloads LL and L, and for me the top link is called VisIT downloads. So if you click there, and then you go to Lawrence Livermore's VisIT download site. Okay. And then if you look at the executables here, so we're not going to use the 3.0 beta, we're going to use 2.13.3. And if you look at the executables here, there are some for all the operating systems. So if you are going to go with
Executables, is that what you clicked on?
yes.
I'm one click behind you. Yes.
And so you should be able to pick the correct executable out of that list. So once you download that, it will be between like a 100 or 200 megabyte download, something like that. Then it will, whatever you download, will, depending on your OS, will either install or copy things over. I figure we'll spend maybe 10 or 15 minutes making sure that you guys are ready to go there. Yes?
If we have to use the 2-point-something release, are we going to be at a disadvantage?
Well,
The latest is 3-point-something, and I
It-
have to use the 2-point-something because of the operating system support. It's not there.
well, so yeah, I want you to use 2.13.3.
Oh, shoot. Okay.
Sorry, yeah,
Okay.
in case I didn't say that before, the 3.0 says it's a beta release. I haven't used 3.0 yet, so I'm going to stick with 2.13.3. It's the second release, but if you go down, you can see executables all the way down to 2.2. All right, so anyway, so the answer is no.
So we're not on the bleeding edge, just on the cutting edge.
Yeah, this is 3.0 is the first time I've ever seen VisIT release a beta. So just in case, those guys are pretty good, but you never know. Okay, and then so once you have that going, I did another Google search over here for VisIT tutorial data, and for me the second link is tutorial data from visitusers.org, and that's the correct link.
Is it tutorial data is what we want?
Yes.
Okay. Sorry, a little slower than you.
No, that's fine.
I'm there since the same spot. Cool.
So once you see this page, the tutorial that we are going to go through is the aneurysm blood flow simulation. And so you can see it's the top two links there for either a zip or a tar.gz.
Either one.
Yeah, whichever works for your OS.
Right, so it's interesting that you have a cube up here.
Well, this cube is, these are all test data for the tutorials.
Okay.
So none of these are examples of the aneurysm.
Okay.
Those are all.
I have an interesting cube problem, which
Those are-
has to do with small data, not big data. So.
These are all small data sets as well. So all these examples on the bottom of the screen are in the tutorial example data sets here.
Okay, cool.
Okay, so if anybody has a problem with that installation, let me know. And before we start the aneurysm, I'll go through a little bit about VisIT so that the people who aren't following along don't have to sit here for 15 minutes. Okay, so for me, I'm on Windows now, and if I open VisIT. Then this is what happens. So I feel like a lot of times I don't know what the expectations are for Viz software, but here you can see that that VisIT has multiple components. And so the way that VisIT works is that there is a let's see, maybe I can let me see if I can increase the.
So you're not expecting us to be running yet, right?
Yes,
So
that's correct. I'm not.
Okay.
Yeah. So this component of VisIT is called the GUI, and this is called the viewer. And so the GUI is what you use to set up an analysis pipeline, and then after you execute the analysis pipeline, you will generate an image in the viewer. So you can think of the GUI as an interface between the visualizations you create in the data, and then the viewer is your way of interacting with the pipeline. There are also other components of VisIT. So there is a metadata server and there is an engine. At this point, the metadata server is not running, so VisIT will only create the components that are needed. And so, as you can see in the GUI, it's very clearly telling you there's one thing you can do here, which is open. So I will open a data set from my desktop. So I'll open something from the tutorial data. So not the aneurysm, but some of the other stuff. Sort of the main one in that tutorial data file is example.silo. Okay, so since I have used VisIT before on my machine, oh no, that's not true. This is a new VisIT, but I have, as soon as I hit open, you guys probably will not see this dialog that says select options. So as you're installing VisIT, at some point you'll get a window that says which supercomputing center are you at? And if you click on your supercomputing center, it will automatically import host profiles that let you run in serial or parallel on different resources from other places. So for me, I have created both profiles to run in serial and parallel on my laptop, depending on which version of VisIT you get. You may, if you downloaded one that has the parallel libraries included, you may get this. Otherwise, you'll just open a serial engine, and that's fine. So once you open a data set, this is what happens. Almost nothing. So now you can see that in addition to open being ready, I also have close and reopen, but I've also created one of these guys. So this is where you pick the type of visualization that you want to create. So this is the plot list. So as I said before, a pseudocolor plot is kind of the typical. And as soon as you hover over a plot type, you get a list of the scalar variables that you can use to create this type of plot. And so I will look at pressure. Okay, so as soon as I say that, then basically I have created a pipeline in this part of the window. I can use this arrow to look at the full pipeline, and the full pipeline just tells me that I'm starting with this piece of data and I'm ending with the pseudocolor plot. Okay, so I hit draw, and there is the pseudocolor rendering of that pressure variable. So the reason that when you pick a visualization that it doesn't draw automatically is because, again, if you have a 10 terabyte data set, you don't want that automatically being run in the background. So for instance, if I add an operator to this pipeline, say, so you can see here in my window that this data goes from 1.1 to 5.7. Suppose I want to make a selection I want to pick specific values to show. As soon as I put an operator on that pipeline, it gets rid of my image for the same reason, because we don't want to redraw things every time we do something. So by double clicking on anything in the pipeline, so if I double click on the pseudocolor word, I get the plot attributes for the pseudocolor plot, where I can do things like change data scales or colors, opacities. If I double click on the threshold, I get the attributes for that operator. And so right now I'm going to change the min to 3 and leave the max where it is. And then to actually do anything in VisIT, again, you have this apply button. So now that I hit apply there, my pipeline is ready to go again. So I can redraw. That was obviously not a great choice, but you can see that I have chopped out a few pieces of the data set. So if I go back into threshold and change my min to min and max to 3, and now I hit apply again, now you can see that I've cut away a good portion of the data set. The thing about the viewer, you can just click in here and drag to rotate. You can see that there's currently a that this is perspective projection. So I can click on this little box here to change it to orthographic. Or the other important parts here for the viewer are these things are cameras. And so if you hover over any of these, you'll see what the option is. But undo view, just change the last thing that I did. And then you'll use a lot the camera with the X over it, which basically just says reset the view. So now this is back to the front-facing view. All right, are there any issues with the installations yet? Yes.
Any issues with it verifying because it's not
Right. Okay. Yeah. So you'll have to go in and run it from the applications. You'll have to right-click on it in there. Open your launcher thing. Yeah. Find it in there and then right-click on it and open it, and then it should give you the option to. Just yeah.
So when it asks for us for different things, do we just take the defaults?
Yeah, that's in a different data set. So I didn't ask you guys to download that one.
Should we just choose the default components?
For
It,
yes, yeah, that's fine.
just run through all the defaults.
Yeah, the defaults should work.
It's all
Okay. Are there any other problems with installations?
We had the 3.0 version installed. It's pretty slow with the other one. It's still installing the components. Well,
Died on the data download.
All right, so in the meantime, I'll show you a few more things that VisIT does. There's a volume plot that we can look at. So the default volume rendering is something called splatting, but we can also change this. So inside the volume rendering, the reason this has such a terrible quality is that the sample size is been the default for like 15 years, and so now even the test data is big enough that you literally want to change that by at least an order of magnitude. So I added a 0 there, and when I hit apply, you can see that it's much finer now. Under the transfer function button here, you can see what the distribution of the data is. So I can change. Say, so the freeform, I could cut this stuff out, and now we're looking at just the very high and very low values of the data set. We can change the color map to something that won't get us in trouble. So now we're looking at high and low values, and of course we can also change from splatting to something that does a much better job. So if we look at raycasting compositing and hit apply, this will actually take some time. And so here you can see that this is telling you how done you are with what you're asking for. Another thing I like to do is come up to File and Compute Engines. And so if you click this will give you the information about your compute engine. So it will tell you that I'm currently running on, this is my machine UFB, one processor, and I like to actually post this, which will stick it down here. And so when you're running, this will give you information about what exactly is going on. This will tell you.
Can we access the data set that you're working on?
You can, but I'm going to walk through step-by-step aneurysm once everyone is going. Yeah. We'll do some similar things with that data set. yeah, so now that I've changed the rendering here, you can see that it's telling you that it's extracting sample points, and then it will be compositing or communicating samples. Yeah. Another thing that is interesting, and this is where if you had very specific questions about how to do analysis in VisIT, if you look at the controls window, there are all these sort of this deep menu of things that you can do. And so there's an expressions control, and this creates a dialog that lets you specify your own variables. And so if I hit new here, and I had that variable called, what was it called? We'll look at radial. So before I do that, I'll show you what this radial variable looks like. All right, so the radial variable, as you can see, it has a 0, 0 right here. And then what you're looking at is the Euclidean distance of every point from 0, 0. Okay. And so the min and max is 0 and 34.64. And I can open this expressions window and create, we'll name this thing simple. And I could say this thing is 2 times radial. So now I've created a derived value, which is simply the radial variable times 2. And so if I come over here, this variables button here allows me to change the current variable for whatever my current plot is. So I'll change this to simple, which now shows up in my list. So once I do that, as you can see, nothing changes for the visualization, but the min is 0 and the max is now 69.28. So you can see that I have scaled the data in some way. And so we can do something, for instance, let's see. The interesting thing about the expressions is that in addition to being able to insert variables directly from this menu here, you can also insert these functions. And so this tells you all of the different things that VisIT has implemented already that it expects you to use in creating your derived quantities. And so if you look at simple math functions, then you can see kind of what you would expect from typical programming. But if you look at vectors, then we have cross products and dot products. There are tensor things here, so you can calculate, for instance, a gradient of a vector and get a tensor out of this, and then VisIT knows how to do things with tensors. If you look at if you come down to miscellaneous, you can see a lot of really complicated things here. You have curl, which you might use to calculate sort of a swirliness component of a vector value, or divergence, or quadrature, gradients. So these things are incredibly complicated things to calculate. And so if you know where to look and how to combine these things, you can get them to do some really extensive analysis on your underlying data before you actually do any visualizations. All right, so are there other issues with installations, or is everyone ready for me to move on with the actual tutorial?
So downloading the data, I seem to be stuck.
Okay.
11 minutes left, and it's not.
Does everyone else have the data and VisIT?
Cancel it. Try again.
I can put it on a flash drive. Let me get you up to speed. Do you still have my flash drive from, is it in your machine over there still? Yeah. Is there anyone else that needs the data, or everyone else is good to go?
Oh, ready to do
What's that?
Where do we get the data?
The data is
Oh, it's-
Here. the aneurysm tutorial data.
If you Google it, if you go, if you Google, so open up a new tab, Google it, and type in visit, so we need to put it in any specific application, visit
Nope.
tutorial data, visit.
VisIT.
Thanks. As you can see, even this isn't all that fast.
Still working on it.
Did the binary work for you?
I'm still working on it.
Oh.
I just clicked the tutorial data, I just click this.
Get,
Visit users.org.
What is the URL at the top of the page? Click on it.
Where was all that radio stuff?
That is also from the tutorial site, but it's
get that it was a different data set. I just meant where was that operator?
oh, that wasn't an operator. That was an actual variable in that data set.
Ah, okay.
Here you go. Yeah, the expression window that allows you to create new stuff, that's in controls expressions to do the derive
It's gonna work
variables.
with the aneurysm data set, but you download
Those I've been able to figure out, 'cause those are
so it may contain everything.
Right, so just grab the whole folder.
Download it.
Yes. Yeah, either of those two.
Doesn't read the zip file.
Right. Oh,
It doesn't. I'm gonna get an error message now here. Yes, ma'am. I was just,
yeah, we'll go through the
find a
we'll go through the menu and see if it's
So
it's
here's,
broken in there as well.
We're gonna download this version. Go to visit.
So yeah, inside my
Execute all. And then
let's see.
scroll down. A little bit more on whichever operating system.
So if you go through this open menu and navigate to that directory, and then open the .visit file, do you get the same error there?
We can move this folder to the desktop.
So inside the aneurysm tutorial data, you should have one file called aneurysm.visit, and it should be pointing to, I mean, it is a text file. You should be able to open it and read it if you want, and it points just to all of the data that's inside the aneurysm folder. Did that work for you?
No,
It's still, you got the same error?
yeah,
Oh, that's insane.
thinking to borrow the USB drive. Right,
Oh, is this the?
Sorry.
Yeah,
Oh, this is crazy.
I chose.
Oh, hold on a second. Let's.
putting the notice in there.
Where you at back there?
Still trying to install it.
Then there's a control receipt.
It's not giving me options.
Version control receipt.
Yeah, try
Fairly agree zones.
Do you want to assist?
Yeah, if you can help me out. So I got here,
Are you having problems too?
I can't find it.
I have it downloaded and extracted.
Yes, after you download the zip file, you have to
figure
Okay,
out
that's
starting
right.
to get line.
All right, so everyone who has the data, try it for now to navigate to that through the VisIT's open. Did that work for everyone? Except you. Okay. Is everyone else got it open though, right? Okay.
I can't seem to get, how do you get it to like,
Oh, this
accept,
was
you have
just
to
me
actually
trying
type
to
it in?
use another
You
website
can't,
to try to find
like,
out.
if you don't
Because
know
it was
your
it's
file,
hard.
you just type it in. It's just the one to go around.
Did you put it
It
on?
should be.
Well, I extracted it though.
Yes. So you should be able to back
Yeah,
up all
just
the way
do it,
to.
yeah. I have time to
Because
learn
you're
version
doing
right.
extracting, you have
So now you can.
Yeah, I don't
There's
think it's
different
a,
ways to extract stuff.
it doesn't include here, so it should have extracted it, right? So it's different.
I mean, so picking in profiles for transformation.
I suppose we'll have to stay super different next time. Because that's the one.
All right, so while we're waiting for just the last couple stragglers we have, I'll show you if if you did want to connect to a separate resource, you're connecting to a supercomputing center that supports VisIT, then the way that works is that you come to options and look at your host profiles. And so under the host profile, so if you, I heard Amy say that she looked at Ohio Supercomputing Center. So now if you open this host profile windows, you should see the names of the computers at that center listed here under hosts. So that if you have to set this up by hand, you can do that. You can also come over to remote profiles and hit import, and this will show you all of the places that there are developers that have added the specific host profiles for their sites. So again, this is mine, but there's only just one host for Blue Waters. And so you can import that.
What does it say under Ohio Supercomputer Center?
Owens.
One on Owens.
Right. So, and for this, if you say you want to create, good grief, where'd it go? Under host settings. If I create new host, this will automatically create one for whatever machine you're on. And then so you could come in here and say, okay, there are going to be two profiles, one for serial and one for parallel, and then you could tell it how to launch a parallel job on your machine. So if you have InPitch or OpenMPI on your computer, you could go in here and say, all right, launch a parallel engine and use MPI exec, and then VisIT would know how to launch an engine in the background. All right, so all right, let's move on with the aneurysm. Sound good? All right, so everyone has this thing open now. So let's start to take a look at this data set. So we're going to come to add. Let's look at a mesh plot first. And so as soon as I hover over mesh plot, I'm seeing all the meshes in this data set. And this, it has one mesh called mesh. So I'm going to add that and hit draw. Okay, so you should see this as soon as you hit draw.
Sorry, where was draw?
Draw is just above the pipeline viewer. All right, so once you have the mesh plot here, you can spin this guy around, take a look. And so the purpose of this data set, this was created by simulation scientist at the Swiss Supercomputing Center. And the purpose of running this simulation was this big bulbous thing at the top here is the aneurysm. And so it's to look at the impact this aneurysm has on blood flow through this vessel. Okay? So now we can come in and change some things in the mesh plot. So I'm just going to double click on mesh. Alternately, you could come up here to plot ats and go down to mesh again. That opens the same window.
You double click on the mesh over here in the.
Yeah, in the pipeline viewer, double click here,
Okay.
or come up to plot ats and mesh. All right, so now in here we can customize the kind of things we're looking at. So let's see what else would be valuable to show you. Over here in the viewer, before we do that, I'll point out these are the navigation modes. I mean the interaction modes that VisIT has. And so by default you have that compass, which if you hover over it should tell you it's navigation mode. It doesn't. The magnifying glass next to it, if I click that, oh, I didn't have the window thing. Now, when I click in the box, instead of dragging the data set, I'm actually going to create a new viewport window. So if you can see that. Now, if I let go, it's going to zoom way in on that part of the data set. Now, this, if you're running on a giant data set in client-server mode, this will kill you. As soon as you log in, you're probably going to crash your server, because if the data set is distributed and you zoom in on something that's held only on a single core or on a single node, then you've basically changed your entire pipeline to for the entire thing to have to be calculated on one core. So this can kill you quickly, especially when you forget that you're in this mode and you go to rotate your data set, you zoom way in somewhere. All right, so if you decide you want to zoom in and take a look at something, that's how you can use it. Otherwise, go over, stick with the navigation mode, and then so in any mode or in the navigate mode, you can on your Mac at least the 2-finger drag will zoom. Okay. All right. Are there any questions so far? All right. So if we play with the mesh properties, the mesh plot, we can see that there are some colors that we can play with. So the color of the mesh is actually the color of your lines. Oh my goodness, let me change that back to black immediately. Okay. The opaque color is the color of the area between the black lines. Okay, so now we can make that opaque. And then the opaque mode is whether or not you're drawing that opaque color. So if it's auto, what that means is if you don't have another plot in the same window, then you'll see the opaque color. And if you do have another plot in the same window, it will only draw the wireframe. So for instance, if I turn opaque mode off, then I'm looking at only the wireframe of the mesh. So this is just the outer edge of the mesh. Okay. But see, now if I turn on show internal zones, no, I don't want to do that. Now I'm looking at all of the zones inside the mesh, which you can see there are tons of them. So if we zoom way in on just a little tiny bit, then you can see all of these, the different tetrahedra that are internal to the mesh. Another thing you can do is if you're in navigate mode, if you hold down shift, you can pan that way. So if you hold down shift, you can just grab and sort of drag the data set so you're moving along instead of actually rotating. Okay. So I'm going to put this back on auto and get rid of show internal zones. Did I hear uh-oh?
No, I said okay.
Oh, okay. So I showed you briefly the expression controls. Something else that we do a lot in after we generate an image is we want to figure out. We want to look at the actual statistics that we can get from the result of our pipeline, right? So now if we look up in controls and down at query, this pulls up a window with a ton of pre-implemented things that we can ask about our data set. So right now we have this mesh plot up. We can change the display to mesh-related queries. And then we can see all of the things that we have here. So if we look at, say, the number of nodes in the data set, we can hit query, and we see that the number of nodes is 25,000. If we look at the number of zones, then we see that the zones is 130,000. So then we know at every node how many pieces of geometry are connected. We can divide the two, right? Now the reason for the original data versus actual data, I'll show you why that's a distinction. So I'm going to come over here and add an operator to my mesh plot. I think this will work. We'll see. I'm going to add a slice operator to my mesh plot. I'm not going to change any of the attributes of the slice plot. I'm just going to hit draw. And it didn't like that. Okay. Pardon me for a second. So now I have to change the attributes. I'm going to make it along the z-axis, and I'm going to change my intercept to 50%. Okay.
The slices, is that an operator?
Yes, the slice is under operators, slicing. Then there's an operator called slice. Yeah, you don't have to follow along with the slice part. I'm going to show you what the impact this has. So now I've changed the pipeline so that instead of looking at the entire mesh, I'm looking at one slice through the mesh. So you can see I've created these sort of disjoint areas. So now if I come back to the query window and I query again for number of zones, it tells me that there are 1,600. So now the query operator is actually telling me what the result is of the image in my pipeline. But if I change this to original data, then it will tell me that the original number of zones was 130,000. So that's the purpose of original versus actual. So you can make changes to your pipeline that have resulting changes for your visualization, and then you can query the results both from the original data set as well as the result of your pipeline. Okay. Let's see. All right, let's take a look at some of the I'm going to get rid of all this stuff that's open. Let's take a look at some of the scalar variables now. So let's add a pseudo-color plot of pressure. And then I hit draw. So now we're basically showing what we said before about the fact that now by default the mesh plot is no longer in opaque mode, it's now in wireframe mode. So it's drawing the mesh, just the mesh lines for the external face, right on top of our pseudo-color plot. All right, so now, again, let's change this color. We'll get rid of the rainbow. So I double-clicked on the pseudo-color attribute, double-clicked on the pseudo-color plot to pull up the pseudo-color plot attributes. Okay. And then there's a color table button here that allows us to change from rainbow to whatever is available. And so you can see, if you guys follow the color theory crowd, the Matplotlib recently got pretty good press for adding 4 new really nice perceptual color maps. They are now in VisIT, and they are Magma, Plasma, Inferno, and Viridis, if you're interested in those. But so the tutorial information for the aneurysm is online. You could find this later and go through it. So the color map that they use there is spectral. So we'll change to spectral, which is a nicer. It's like a dual rainbow. But now what we've done is if you look at the plot, we've made the blue the high values and the red low values, which is counter to what we think of. So we'll come back to the color table part in the pseudocolor plots and invert this. So there's a little checkbox next that says invert, which will now we can see that we have moved the red to the top and the blue to the bottom. Okay, are there any questions?
Where did the pressure data come from? Right, this is an MRI image. How does it calculate? Is there an algorithm to calculate internal pressure? Or? Simulation.
Yeah, it's a physics simulation that generates that value. All right, are there any other questions? Okay. All right, so let's look. Now let's look at the queries again. Oh, actually, before we do that, so let me come to the aneurysm data. So I'll show you on disk. This is the file that we open. The actual data is, you can see 200 silo files, and so each one of those actually corresponds to a separate time step. So before we go any further, we'll see that when VisIT opens something that it knows is a time series, these controls are available to use now. So if we look at file, where'd you go? File information up here. We can see VisIT will tell us everything it knows about this file. So there's a mesh called mesh. There's a number of blocks. This will be a higher number if your data is spatially decomposed. So if you have 16 files on disk and they correspond to little bits, you'll see 16 there. And it tells you that there are 200 time steps with these cycle values. And then these are basically these are things that VisIT kind of creates for you based on your mesh values and your scalar values. So anyway, if we just hit play here, then you can see VisIT down here. Since I have this thing telling you what the engine's doing, it's going completely crazy, and it's reading in every time step, and it's just splashing that time step directly onto the onto the mesh here. Of course, you'll also notice that every time step the maximum and minimum values are changing. So this is, you would not want to create a video this way. It's technically incorrect to have this time scale changing. Okay, so I'm going to stop this and move it back to the beginning. All right, so now we can do, let's go back to the queries. We're going to look at a query for this data. So remember, I told you that the queries will give you the information based on whatever the visualization you have is. In this case, we have to pick one of the two visualizations. We have two plots. So before you do this, make sure that sorry, I keep seeing my mouse on this one. I try to go over the other one. Make sure your pseudocolor plot is the one that's highlighted before we can do this next part. Okay, so I'm going to go to controls. And before we do the query, let's change the query over time option. So click on the query over time. And you'll see what this is used for as soon as we do it, but we're going to change the x-axis from cycle to time, and then hit apply. Okay. Now let's come back to the controls query. And we're going to change from mesh-related display to variable-related display. Okay. And then we're going to look at max. Okay, but so we could do a query just like that, and it will tell us what the maximum pressure is for this time step, and it will tell you exactly. It will tell you exactly where that maximum is. It's at node 5, which is these actual coordinates. All right, but we actually want to do a time query. So we're going to click the time query box, and what this is going to do is it's going to calculate the maximum pressure over the entire data set, over the entire time sequence. So I'm going to hit query, and you will see VisIT going crazy again. So now it is reading in every time step, it's calculating the maximum value, and then once it's done, it's going to show you that maximum value plotted against the time for which that maximum value was generated. So this is now a plot of the maximum pressure for overall time steps. So you can look at this and tell how many heartbeats, for instance, that this has been simulated over, right? You can see that this is 2 heartbeats. This is similar to these sort of, what do you call them, EKG readouts or something? Okay, so that's query over time. Are there any questions about that? No? Everyone is either really lost or really found. Okay. Let's see. So there is there's another variable on this data set. So I'm going to get rid of. I'm going to delete both of these plots. So you can see here that there is one more. So these are things VisIT offers. Operators are something VisIT offers. There's pressure, simple, I created, remember, in the expression window. Also VisIT offers. And then there's velocity magnitude. So by default, if you have a vector variable, VisIT will automatically calculate the magnitude of that. So you could look at the pseudo color of that. So if I come over here to vector plot, I'll see that there is actually a vector called velocity in this data set. But for now, so there's pressure and velocity of the flow. We'll just look at a pseudo color plot of velocity magnitude. Okay. And then I'm going to go in and change the colors table exactly the way I did before, from hot to an inverted spectral. Okay. So now we're looking at the velocity magnitude. And so if you want, you could hit play again and see how that changes. You can see that this one changes a little more interestingly than the last in terms of this little teeny tiny area, but you can't see anything else because the velocity at the walls of the vessel and the aneurysm are blocking everything, right? Okay, so I am going to now we're going to start looking at a way of getting a sense of what this data set looks like inside this blood vessel. So I'm going to hide this plot for now, and we're going to add a frame of reference so that when we're looking at the blood flow, we can still see the bless you, the outer edge of this plot. All right. So here we're going to add a subset plot of the mesh. We can go ahead and hit draw and look at that. Okay, so you can see what this is just a giant chunk of the. This is basically the opaque values for the mesh plot.
So did you say there's a tutorial that basically walks you through all these steps?
Yes.
And where's that at?
It is very close to where you found the tutorial data on VisIT users. So when I search for VisIT tutorial data, you can also search for VisIT tutorial. There you can find there are 2 or 3 different scientific visualization data set walkthroughs, and then there's also like VisIT basics and loading data set, things like that. But yeah, the typical tutorial at like SC or something is usually a half day. There are some that are nothing other than getting your data into VisIT that are like full day tutorials. So that's kind of insane. Okay, so now I'm going to double click on the mesh plot and change the color to that same light blue we were using. And this time I'm going to change the opacity down to 25% with this slider here. Okay. So now what we're seeing is just the outside of this vessel. And now it's nice and transparent so that we can see things inside. All right, so now we're going to come back to the pseudocolor plot and unhide it. So this completely destroys our subset plot. That's fine. And then you should, by default, have this arrow apply operators to all plots checked, which means that if I were to come in here, the expectation is that you're always looking at the multiple variables in the same context, and so that if you did a threshold, for instance, of say you only care about where radial is close to 0, the expectation is you would want to threshold all of your plots based on that. That's why that's checked by default. We want to uncheck it, so make sure this is unchecked because we have this mesh plot. The subset plot is to show us the outside, and then we want to apply operators to the pseudocolor plot so that we see what's going on inside. So we want to keep both in different contexts. Okay, so now I'm going to highlight the pseudocolor plot, and I'm going to add under, let's see, I think it's slicing. Yes, under slicing, add an isosurface. Okay, so now that makes our pseudocolor plot go away from the window. So now I'm going to click this arrow to look at my pipeline and double click on isosurface. And this is the isosurface operator attributes. And so I don't know if you noticed the values of the previous plot before we undid it. Actually, let me just, you can hold tight right at that spot for a second, but I'll hit. Look at the vector plot again. We can see that it goes from 0 to 15. So these are just values that you can find in that tutorial that will basically tell you the right values to add here. So I'm going to go back and add this. Okay, so we're going to make a selection of isosurfaces, not by n levels, but by values. And then in this box, we are going to look at values of 10, 15, and 20. Okay, now I'm going to hit apply. Don't forget that. I'm going to close this and draw that. Okay, so now I'm looking at the isosurfaces associated with those three values. As you can see, there may only be 2 of those isosurfaces that exist in this data set. Excuse me, at this time step, but there they are. So now is a good time to hit play, and now you can see these the change in these as this thing is playing. So as the blood is pumped through this vessel, when it hits sort of the high pressure areas, you can see how little blood is there as going back to the heart versus coming in. And so now if we watch until, we know near the end of this there's another heartbeat. So if we get to the end, here's the second heartbeat. Boom, blood's going in, and then we see this is the part, obviously that's the problem. That shouldn't be happening. Okay. So I'm going to stop that. The thing about the isosurface, let me get a little better. That's a little unfortunate, of course, if I zoom way in on this guy. I've basically created sort of 3, let's face it, ugly sort of pieces of geometry that we're trying to follow. So there, see what I did there? I forgot to undo my zoom thing. All right, good though. So now, instead of, I'm going to get rid of this isosurface operator, and I am going to add, it's not under slicing anymore, it is under ISO volume. Excuse me, under selection. The operator is ISO volume. Okay. Okay, so for ISO volume, we're going to make the min 10 and the max 20. So this is analogous to what we were doing with the ISO surface. Hit apply, don't forget that, and draw. Right, and so now we see that even in this example that I have, I've still cut some things out. So I'm going to change the upper bound to just be whatever the max is. Okay, so now we have a lower bound of 10, upper bound of max, and what we've ended up with is sort of good grief. Now we have the full range of high values. So now if you hit play again, you know, you could zoom in on what happened there. Oh, you don't want to zoom while that's playing, obviously. Yeah, so now that we have the maxes, the high values, we can see how this thing is changing inside the vessel over the entire time. All right, are there any questions there?
Is there a minimum like compute power you'd expect to do this, like just on a small scale? So obviously, we're all running it on computers.
This is an 8-year-old laptop.
Yeah, no, it's pretty impressive. That's what I was just saying. Is there anything?
Well, so all of these plots so far they do run on your GPU, whatever it is, and like I said before, these plots are all topologically 2D, so there's not a ton of processing required. So I would say if whatever fits in your main memory on your on any machine, this is going to be good enough to do directly. As soon as you need to parallelize on the back end, then wherever that parallelization takes place, the engine will be the same way in parallel. But so yeah, if you have an 8-year-old laptop and you were to change the pseudocolor velocity magnitude to a volume rendering using raycasting, that might take you 5 or 6 minutes on this machine. Whereas I have an NVIDIA card on this machine, it would take maybe 15 to 20 seconds. But yeah, it depends on that kind of plot. So the splashy kind of images, all the images I showed in the presentation earlier, those were all raycast volume renderings, and yeah, those would destroy your laptop. Other questions? Okay. Well, how about we take a 3 or 4 minute break and give my voice a rest, and I'll come around if there are any issues.
Please eat more pizza.
Yeah, eat more pizza.
Is there a drinking fountain in this building that's got some lock?
The one I know is there.
Data file structure.
Silo?
Yeah.
So those are silo files. Sure. Silo is a file format that was created at Livermore basically for this purpose.
Okay. And how can we?
So that
create the silo?
there's an API in Silo just like NetCDF or HDF5.
Oh, okay.
You know those file formats?
Mm-hmm.
So yeah, there are a bunch of, you consider them IO libraries that are made to, they have a specific data structures. You have to fill them, and then there's write calls. So if you typically run out binary data, if you typically do that, there's a way that you can create a header file that will read those in. But
So usually I'm doing statistics.
okay,
So usually our data.
spreadsheet.
You need spreadsheet or text or whatever.
Yeah. So there's
How can I
also
transform?
sure. So if you, I'm going to open the open database here.
Yep.
So right now, VisIT is opening the file. It says guess as
Okay.
from file extension, right? But if I look at this, then all of the file readers are here.
Oh.
And so if I change this to, let's see,
Excel file.
there's one called plain text.
Oh, plain text.
And if I open the default things, it will tell you
Oh, okay.
that the data that you're putting in are 1D columns. You can skip lines at the beginning. The first row has variable names.
Oh, okay.
Yeah.
Yeah.
So, yeah,
Great, great.
there are a bunch of, and they're all different kinds. So, depending on how you're already doing it.
So then the data file, it should have XYZ.
Yes. Well, so if you look at the default options here, it will tell you which column has the X, which column has Y, or -1 if you're 2D.
Thank you.
Because I've changed ours, we had research services in general, just change it to research.
I think I've seen that. We have at least does elevation. And so did that every few years. I mean, it wouldn't be because of 200 years. I hated to do that. But laser scanner and flew over the same area today. Huge file.
It's just the important plain text.
This is just fool. The actual resources.
So that might just be a separate. And I, more I look at that, it's some ideas, so this was the group. So there's a very specific group.
Did you ever get VisIT running on?
No, he was trying to help me out. I don't know if it was a version problem, but I didn't want to distract anybody. I'm actually probably going to head outside of the office. Yeah, sure. See you at the next workshop.
Everything they told me to do, but they're just like software is just weird.
Just follow it on this thing.
I don't know why the data download quit running. It started and quit.
Very.
Your University of Illinois.
Yes.
You know where Killarney Street is? Right
Uh,
off the interstate.
it sounds familiar. I'm not so good with directions and places, space, and time.
We were on our way to North Dakota a few summers ago. We got the exit right to go to the street. It's like, I recognize that street. The company I used to work for is on Killarney Street.
Okay.
Never
Yeah.
worked in the office, but I traveled there several times.
Gotcha.
The company was founded by a couple
So
of
if I can
engineers from University of Vermont.
Oh yeah.
The whole city was. I'm sure there's numerous small companies.
But it's still like, I was trying to figure out my camera. I was trying to do a conference call. It's kind of work. And then I was like, no volume, no mic, no camera. Got the volume and the mic to work, but then I couldn't get the camera to work. And then I somehow my mic and my camera, or my mic and my volume to work.
Me, the Y source.
The EOB files and data saying
Even better on
this data set has this many red points. Here are the
So you picked a different flavor.
That right there is the problem. Is there's all these different spin-offs. And so like you just because I don't need this version that I no, quite frankly, when there's so many of them, that's not
That's what
Google Ubuntu, whatever you get, that's the one. I had no idea, and they were like, this one's similar for Windows users. It's a nice transition. I think it's we all operate.
All right. So, are there any other questions before we move on? Nope. All right. So, for this next bit, we'll look at the vector data. Is everyone ready to look at that? Yeah.
Let's do it.
All right. All right. So let's get rid of this pseudo color plot we have, so that we're left with nothing but the subset of the mesh. And now let's add a vector plot of the velocity. All right, so by default so I'll change my time step back to 0. This is what the default vector plot looks like for me. So now let's change the values of the vector plot so that we get some better looking stuff. Okay, so first, under vector amount, we're basically telling it show us 400 vectors and spread them out throughout the values. Instead, we could say stride 1 means show us every vector, but we could tell it to show us every 5th vector. So if I hit apply here, we'll see now that I'm looking at many more vectors than just the 400.
Oh, cool. You're looking at the first frame? Okay, that's what mine's doing.
Yeah. Okay, let's change this color again. From the default, we'll go back to an inverted spectral. Okay, that's looking better. And then under glyphs, and again, these are values that come directly out of the tutorial, so I don't know how they found this magic value, but change the scale from 0.25 to 0.5. And then we're going to change the arrow body from a line to a cylinder. So this will make, instead of drawing a single line in there, we're drawing a little tube for the vector body. Okay. And we are going to tell it to give us high quality geometry instead of fast rendering. Okay. So now let's hit apply there. And your plot should now look like this, where we have some fatter vectors and higher quality tube renderings. Okay, so now's a good time to hit play again, and we can see how this vector field changes. That's the beat. Yeah. So this one is obviously a little more intensive to generate. So if it's a little slower, that's why. Okay, I'm gonna stop that. All right, so this is it's looking at every 5th data point and it's showing you the direction of that. Often with vector plots, we want to look at streamlines, which give you a sense of the entire flow. You have options. You can either create a streamline for a single time step, which it gives you an idea of how flow would transition if it was unchanging over time, or you could actually make the flow transition and get a sense of what's going to happen to the streamlines over the lifetime of the simulation.
Are there hotkeys for zooming
You
out?
don't need that
Or
one.
just the scroll wheel?
I'm not sure. I'm sure there are, but I don't know.
Are there even buttons for it? That's what I'm just missing. You're just using your.
So if I let's see, if I left click on here.
You're just using your trackpad to scroll, right? Like when you zoom in and out.
I'm using just 2-finger scroll.
Okay.
Oh, most of the time I've been switching over to the magnifying glass and highlighting an area.
Okay. All right. There.
But then I always forget to change back, and I end up messing things up. All right, so we'll look at streamlines now. So let's get rid of our vector plot.
That was cool.
So the thing about streamlines is that you have to pick where the streamlines are going to be seated. So the way you generate streamlines, use a particle advection, which is taking a set of massless particles and seeing how they transition through that flow. The thing about getting that plot is, of course, you have to pick where those particles are seated, where those seed points begin. Okay, so I'm going to add another pseudo-color plot of velocity magnitude again. Okay, and then before I draw that, I am going to add a slice operator. So go to operators, slicing, slice.
So rather than delete the velocity plot, could we hide it?
You certainly could.
Okay.
Okay, so now I'm going to look at the slice attributes. We're going to keep the normal orthogonal to the y-axis. And then under the origin, we're going to change this to a specific point. And make that point 3, 3, 3. Okay, and then under the up axis, uncheck projected 2D. So by default, no matter how you slice through a volume, you'll be looking at the result straight on. Whereas if you have a volume like this and you take a slice right down your eye line, if you don't project to 2D, you'll see nothing. You'll have to rotate the data set to actually see where that slice is. So since we want to keep our slice in the context of the original 3D data set, if you don't uncheck that, you'll get an error saying that it doesn't make sense to plot that 2D plot on top of a 3D. So now we hit apply and draw. And so you can see the purpose of making the slice point 333 is basically just picking an area that's kind of close to the inlet of this blood vessel on the data set. Okay, let's see. I'm going to go ahead and change the pseudo-color plot yet again to match what you see in the tutorial documents by getting rid of the hot color table, going back to an inverted spectral. Okay. Now let's go make sure this little slice nugget is highlighted in your my brain is broken. Pipeline viewer. Make sure you've got the pseudo-color plot highlighted. And let's go back to controls and query. And now this time we are going to do a max again. We do not want a time query this time. Okay. Make sure that if you're not already, make sure you're looking at time step 0. Make sure you're looking at only that one. And then we're going to do a max query of the actual data. Okay. Are there any questions about that so far? No? Good? All right, so the purpose of this, we don't really care what the maximum value is in this case. We are actually finding the specific coordinates on that circle that's left from the slice of where that maximum velocity magnitude is. So we're going to use these numbers in just a second. So I'm going to just move this guy over to the side. Okay. Now we're going to add. So I'm going to. We're going to keep this, but I'm just going to collapse the pipeline for the pseudocolor, and we are going to create a streamlines plot. And so there used to be a separate streamlines plot, but the PIX, the particle advection, what is it? The integral curve is what the IC stands for. It's the VisIT's particle advection library. They converted it to work as an operator now. So now to get a streamline plot, what we really add is a pseudocolor of, and then highlight operators. And so as you can see, these are the plots that that VisIT's operators have the capability of. These are the operators in VisIT that are capable of creating new variables. And this is actually a functionality that I added to VisIT back when I was at Oak Ridge still. The ability for operators to create special variables that you could then plot. So these, you'll notice the data binning is one where you could actually create new variables that are the results of your data binning. We are going to create an integral curve of velocity. So I know that's a lot of menuing there. All right. So now that we've got that, let's open the integral curve operator attributes. And we are going to set the source type to a circle. Okay, so then when we do that, we have all these ways in which we can define the circle. And so under the origin, that's where we're going to use the values we found from the query. So I can see those values here. 3.45419. I'm going to just type those in. So 3.
You can't cut and paste in that box.
Yeah, I can, but it has commas, and it makes me crazy. So I just prefer to type it in than I always delete one too many things.
You can't just get rid of commas.
You can't.
I always hit delete one too many times when I'm getting rid of commas. So this is a personal failure on my part. See, I typed that way in wrong too.
Yeah.
Okay. So we've got that. Let's see. The normal now should not be the z-axis; it should be the y-axis. Because again, we want to start on that circle that we specified was the normal to the y-axis. The up-axis we do want to be the z-axis now. And the radius, this is another one that you have to just take my word for, 0.12.
Is there anything that gives you like throws you a bone about what order X, Y, and Z are in the 0, 1, and 0? Because in math class, it's like, usually X, Y, Z. It looks like you made Z was the middle.
This is the only bone that you get.
Z was the middle number again?
No, Z is the end. It's X, Y, Z is always the way it's ordered.
So what do they mean by the up axis? We get normal, but
So that is something that tells you how to light the geometry.
oh.
Like where the light source is hanging from?
Yeah. So depending on how you pick the up axis, you'll choose whether one side of the polygon or the other is the one that's lit.
Okay.
Okay. So then in sampling, we are going to sample along the boundary instead of the interior. So we're going to be sampling around that circle of radius 0.12, and we will take 12 samples. Okay, now if we come over to advanced, let's uncheck all of these warnings. In general, when you are running the particle advection, you will see tons of warnings about things where maybe if a particle is in a vortex and it has to be integrated 1,000 steps or something, you'll see warnings for all these things, even though they're very common. All right, so let's click apply and get rid of that. And what happens if we draw? Okay. So now we have streamlines showing exactly what happens with that flow. But again, we want to change the way this thing is looking. So now instead of the integral curve, we're going to click again on the pseudocolor plot, which pulls up the attributes for that rendering. And let's see. Let's change the color to reds in this case. And then under geometry, we're going to change the way these things look now. We're going to change the line type from lines to tubes. So this is very similar to what we did with the vector plot. We're going to change the tail of that line. So we're going to get rid of none and we're going to make it a sphere. So now what happens is when we change that, we'll see the actual seat locations of each streamline. We'll change the head to a cone. And we want the radius of these to be 0.02 instead of 0.05. All right. So if we hit apply again, now we have a slicker looking streamline plot. And so now is another great time to hit play.
What was the thing that changed the number of streamlines?
That was in the integral curve.
Okay.
Where we told it.
Find reds. You see grays, oranges, purples.
Way down at the bottom.
Is it samples along the line? There we go. I found it.
Samples in theta.
Great.
Changed to 12.
Oh, there it is.
All right, so if we hit play again, then we can see how these things go crazy as the time steps are changing. So again, streamlines aren't really something that you create these types of videos for. You know, each one is a representation. So as this integration is done over these lines, it's specific to each time step. So that's why you get a lot of jittery stuff for every time. Okay, so yes.
When you're in the operator attributes
Yes.
window, is there a keyboard shortcut to hit apply because it does not want to fit on my? It's not scaling to my window correctly, so I can't access the apply button.
Oh,
Just hit tab until you get to the one last button that you can see. So keep it in tab until you get to the
so I would.
It's just tab. Okay. That's
So once you get to make the fall,
Are
it's
you,
like 3 more times.
she's on a Mac, right?
Yes.
So until you get down here.
So here, what if you look under options and appearance?
There are options and appearances.
Get rid of this use default system appearance and change the GUI style. Just try a couple of different ones.
okay.
One of those is likely to have a separate. One of those may fit. And if none of that works, there is another one under, let's see, where is that? There's another setting somewhere, and I can't remember where it is. Where is that? Yeah, this is a terrible issue. We have this. What does that do? It did nothing. Yeah, we're always terrified that whenever we plug into one of these monitors that we won't have that issue because it takes forever to figure out how to fix it, and I can never remember how to do it. There's another way to change the way the layout is, so it'll be more horizontal. Okay, well, sorry, can't help you. I don't know.
I think we got one that works.
Are there any questions? Maybe I can answer a different one.
I'm always worried about how my input file in real life would have to look. Right, you'd have to have the coordinates for the aneurysm, right? That comes from, let's say, the MRI picture. You have the pressure values from your simulation. You just said that there are certain variables that you can generate that you presumably don't have to feed, right? So this is not just visualizing data that I directly put in. There are certain functions where you can actually take data and generate new variables.
Yes. So, yeah, I admit it's a little strange to go from sort of a general high-level Viz talk right into this hands-on. We're sort of completely skipping sort of the groundwork for mesh-based visualization. But in terms of the input data, every VisIT and ParaView, they're built on everything comes back to the mesh, and so you must specify a mesh somehow. Now there are ways. Say you have just you write C code. And you have a three-dimensional array, and you do a single f-write, and you just write that out as binary, right? You could create a header file for that to tell VisIT, this is a binary file. Here's where you can find it. It's 512 by 512 by 512, and there's one variable in it called whatever. VisIT knows how to open that and create that mesh. That's a simple case where if you have a nice regular grid, VisIT can do that for you without you having to specify it directly. These silo files, though, they're all written having specified the mesh. So VisIT opens, it can read that mesh in separately. And somewhere, I mean, there was one mesh called mesh. Someone named it that and specified, because this is a tetrahedral mesh. Somewhere there is a specification of those nodes and how they're connected. And so the data model that all this is built on is VTK. So unless you have one of these very simple, that you can construct on your own, the easy way to think of it is how you would specify a mesh in VTK and make sure that your data format does that. So the silo cases, those were developed by the same developers that did VisIT. Those have a one-to-one relationship with the way VisIT thinks about meshes and the way Silo thinks about them. NetCDF is pretty common for like climate simulations. If you open a NetCDF file, VisIT knows to look for a variable called lat and a variable called lon, and it knows how to put those together into a mesh. But in those cases, the specification of the NetCDF file, every variable says, I exist on lat, lon, and time. And so those are cases where VisIT also understands how to create the mesh, that you don't have to explicitly, although you could make the argument you really are explicitly. So yeah, does it answer your question?
So yeah,
I think so.
Mostly it's feeding the data in a specific format that allows.
Yes. Either you specify a mesh explicitly or VisIT can create one. After that, any of the derived variables are going to live on that mesh.
Yeah.
Anything else? Okay. let's change this thing to a pipeline, path line. So I'm going to move back to time step 0. And then open the integral curve operator attributes again. And then under appearance, we're going to change from streamline to pathline. Okay, so what we were doing before is we were at time step 0, this image you see on the right here, we were taking those 12 seed points and we were vecting them through each time step. So what changing to pathline does is it's going to advect each particle one step, and then it's going to load the next time step of velocity. So you actually have a time varying velocity now. So this is going to create a single image, and it's going to use the velocity from all 200 time steps to do that. Okay, so if I change, let's see, under the pathline options, the mesh, so even though we have a time varying velocity, our mesh is static, so our mesh doesn't change. Okay, so now hit apply, and you will see VisIT go crazy again. It's going out and it's reading all 200 time steps while it is advecting the streamlines. And so you can see here now, out of our 12 streamlines, we sort of have this view of an overall what's happening to this blood flow over the 200 time steps. So you can see that some of the flow that comes in exits exactly as you would expect, and some instead goes up and spins around inside of this aneurysm.
How come you have this window at the bottom? Is that something you turned on and missed earlier?
Which one? The going crazy window?
Yeah, engines and total status, storage status.
So yeah, this was under File, Compute Engines. That will pop up this Compute Engines window. This is the thing that gives you the
File, compute engines?
yes, it's near the bottom.
Okay, got it.
This will tell you information about the engine that's running.
Yeah.
And then I just hit post, which crams it in this little space.
Got it.
Actually, any of the windows that you have, if you open even the integral curve, you could post that. Oh, you know what?
I think that was just thinking.
That could have gotten you apply.
Yeah.
Look at that.
Except post is also on the same X.
Oh yeah. Okay. Well, yeah. There's that too. All right. So now I'm gonna
Okay, cool.
unpost that and get rid of it.
Where's the issue tracker?
It's not me.
We'll follow the issue.
Okay. So that's it for looking at the flow field. I can take questions or requests.
Would you mind showing us the integration tab on the integral curve operator dialog? The first tab in that dialog box. Thanks. Yeah, I think source step circle is how I got it. It's completely sidetracked.
Oh, okay. So there is another part of the tutorial. I'm not sure I can get through it in time. It's for calculating the flux through that little circle inside the mesh. We can start down that path, or if you guys have questions about something you'd like to know how to do, maybe we can do that live. Anybody have any requests? Should we work through the flux? All right then.
So the room is available if people want to hang out.
Okay.
Just because,
Yeah.
you need to leave to get back to
No, I'm good.
Illinois.
Any time is fine for me.
4
I
hour,
will have
4
to
hour
leave.
drive.
Yeah, it's not bad. I stopped 3 times on the way here, and I made it in 4. So. All right. So yeah, I'll be a little bit slower going through this flux part because I've actually I've never had a full hour and a half to do this, so I'm usually having to rush to get through what we just got through. But bear with me, and we'll get there. All right, let's see. All right, I am going to get rid of that. All right, so sure. Now we'll look at the vector plot of just this same slice. So I'm going to add vector plot of the velocity. Okay. And then we'll make a bunch of changes to the way the vector plot looks. Okay, so we're going to change the fixed number from 400 to 40. And then under glyphs, we're going to change the arrow body back to a cylinder and make the geometry high quality. Okay, so now I'm going to hit apply. After those three changes, I'm going to kill this, but before I draw, I am going to add a slice to this plot now. So I'm going to come to operators, slicing, slice. Okay, and then open the operator attributes for slice. And then we want to change the, let's see, what is this? We're going to change the normal to arbitrary. I don't know why we're doing that. That doesn't make sense. We can keep it on y-axis. That should work. And we're going to change the intercept to 3. And make sure that project to 2D is turned off. Okay. So I'm going to hit apply and then draw that. So hopefully what you have looks like this, where we have a, I'm going to zoom in on this little tiny area. Whoops. All right, so we're looking at just the vector field on top of that little slice plane. Okay, so then let's see. Now we have to create a vector expression so that we can look at those values. So let's go to controls, expressions. Okay. And then we're going to hit new to tell it, make a new expression. We're going to name this normals. And we need to change the type from scalar mesh variable to vector mesh variable. Okay. So from here, we are going to insert this function under miscellaneous. Under the surface normal part, we're going to change it to cell surface normal. Okay, everybody find that? Okay, and then inside the cell surface normal, we have to insert a variable. Usually in VisIT, you have a pretty good indication of what each function expects. This one doesn't do such a good job. It expects a mesh variable. So we can go to insert variable, meshes, mesh, and that will drop that bad boy in there. And of course, any of this you could type just directly into that window. But I mean, who remembers things like cell surface normal, all lowercase with underscores? Okay, so hit apply if you can, and then get rid of this window. Okay, and then come back to your velocity plot. Make sure that's highlighted. And then we're going to click on this variables button here to change from velocity to normals. And when I do that, I have an error because I've screwed something up, which you guys have as well, right? So, all right. Well, we're all there together. Let's see what I've done wrong. Oh, okay. Oh, I see. Okay. So what happened here was VisIT doesn't understand what we mean by mesh just yet. So there are cases where if you've done something to your mesh, like maybe take a slice through it, that when VisIT tries to create the expression, there's a difference in what the mesh is both before and after you, say, slice through it, or before you make changes to that. So you have to let VisIT know that it needs to defer creating the expression you just created until a later point in time in the pipeline. So the way VisIT typically works is when you tell it you are going to create a variable, it goes and it reads all those variables from disk and creates your new variable. We want to read those variables, execute the pipeline, and then create our expression. So we have to come up to operators and add an operator under the analysis category called defer expression. Okay, and then open defer expression, and now we tell it which expression to wait a bit to create, and now we find under vectors normals there, and hit apply. Defer expression.
And then vectors.
All right, did everyone else's point downwards instead of upwards? Yeah, so so remember when we were in the slice attributes and I said, oh, we don't need to do that. We can just leave it as the y-axis. Obviously, I was wrong about that. So by default, it considers the y-axis 0, -1, 0. So change from the orthogonal to y-axis to arbitrary, and then type in 0, 1, 0 instead of 0, -1, 0. And you might also have to make sure that your intercept is still a point 3. All right, so then, once you apply that, you should be seeing something like what I have. Does everybody have that now? Yeah, so if yours went away, look and make sure that you still have your origin as intercept in 3. Now, do you have sweet upward pointing arrows?
Well, intercept has 3.
Okay, so at this point, when we have our slice operator attributes up, let's go ahead and hit make default. And as soon as you do that, it's going to say, do you really want to do this? And we're going to say, okay. Or if VisIT bothered you by asking, say yes and do not prompt again. Okay. Now, so I'm going to add another plot. And this one, I'm going to add a pseudo-color plot of operators, flux, and mesh. And so the calculating flux is basically looking at how things change across the surface. So if you had, for instance, a cloud in a climate simulation, and you know the cloud tends to happen at a certain value of some variable, then you could create an isosurface of that cloud and calculate how things are changing across both sides. All right, so once we have the flux operator, let's add a slice to that. So operators, slicing, slice. Okay. And then let's open the slice attributes and make sure that we still have the what we just set as the default. So the arbitrary and the intercept of 3, which we do. And now we're also going to have to add another defer expression. Okay. Let's see. Looks like defer expression needs to go. Oh, I see. First, we need to move the. We want to take a slice before we calculate the flux. Otherwise, we don't have a surface. So let's move the slice up above flux. And then we are also going to move the defer expression up above flux. And then if we click on flux, then we're going to change the flow field from default to velocity. Okay. So I've applied that and dismissed, and then hit draw. Oops. And so now I'm going to hide these vector plots. So now we're actually looking at the flux on that surface, that surface slice down at the bottom. So we're seeing the areas in which there's very little change across that surface to the most change. And so finally, let's see. So we can verify that we have, so we can change the time slider, so we can hit play again. Let's see. Yeah, so we can see how that flux changes. In particular, where the heartbeats happen, we can see that flow sort of whip around in a little circle there. Okay. And then finally, we can get the numerical value for flux by querying weighted variable sum. So if we come back up to controls and query, and then stay in the variable related and look at weighted variable sum, Okay, so when I tried to do that, I got an error because I had the wrong plot highlighted. I had a hidden plot highlighted. You need to make sure that you have the new plot highlighted, and then you can query. And so this gives you the total value for the flux across that surface. All right, so this is completely it now. Are there any questions or anything else I can that it would be helpful for me to tell you?
How about output formats? Like, what kind of press quality, publication quality stuff can we make with a figure that we're looking at in the graphics window? Or is this tool not intended for that?
So there are a lot of little things you can do to make something an appropriate. It depends. If you're looking to submit something to say SIGGRAPH, then no, this is probably not the right tool. But in terms of publication quality or in general, just presentation graphics, sure. There are things like under controls and annotation, you can do things like get rid of all of your annotations, or change your you can change the background color to black, or you can come into annotations and say make it a gradient. So I mean,
you just have to do a screen capture, or can you export it as a?
Yeah. Like
okay, yeah, as how to export. So you have a couple of options for that. You can, obviously that's crazy. So under File, there is a Save Window. That will create a screenshot of your what you're doing. Before, you probably want to play with Set Save options, and so this will tell you where to save that screenshot, what kind of image. You can set any bounds of that image, so you can tell it to whatever the window is, the screen ratio, and then you pick a width, and it will automatically pick the height and dump that out. So you can do that image at a time. If you're in the Python interface and you have this running through Python, you can change that to typing save window will do the same thing. Also, there is there's also a save movie right under set save options, which is a wizard for making a movie. So if you go through this, you can see, okay, I want to make an impact movie, and then it will ask you how many frames per second, what frame do you want to start at, how many do you want to skip per frame, and this will automatically generate a .mpeg for a movie. I typically work in the Python interface and save frames, and then go and use FFmpeg myself to create movies when I'm going to do that. Just because I like having the extra control over frame rate and quality rate. And then the other thing you can do is, if you say, for instance, you had nothing but this little flux guy that was all of your data, and it was all you cared about, then you could go up here and export your database. So that's a separate call that will actually write out the data that you're using, and it will only write out what's needed to generate that plot. So that's another trick that we use a lot. If we have giant data sets and we know that there's only an isosurface they're interested in, we might go in parallel, create those isosurfaces, and then export the data set so we can bring that back in on a laptop and change how we're viewing that isosurface. Or that would also be a case where you might want to export into some geometric format and load it in a separate tool like Blender as post. Other questions?
So if you were trying to achieve like 200 dots per inch or something like that, like a publication was telling you we need this resolution, then you would just have to crank up all the dimensions of the plot in the save options?
No, yes, in save options.
Okay.
So what happens in save options, and this is something else that will kill you completely if you are doing a raycast volume render. So the way raycast volume rendering works is it fires rays through your data set to generate colors, but you specify the size of the image at the end and the number of samples along that ray. And so if your window, so like my laptop is running at 4K, my window could look small, but it could be HD resolution. If I ask for raycast volume rendering, VisIT has to create upfront 1920 by 1080 by say 5000. That's already a lot of data. And if you go in and save options and change that width to 4K, then it will have to re-render at that resolution. So the only way that saving a window is free is if you take a screenshot. Other than that, whatever you set the aspect ratio to be in your save options, it may require VisIT to fire off a separate job to re-render at that correct resolution and then output the image.
What's screen capture? I mean, just get the window at the current resolution that it's displayed to the user? Okay.
That happens immediately. But yeah, if I were to change that to 4K, it would work. For this simple image, it would work. But yeah, even on this machine, if I were to ask for a 4K volume rendering, it would crash. It would run out of memory almost instantly. And yeah, that's a problem that we have a lot. Yes.
So where in the do you go to change like your rendering style? Like obviously this was a really simple render. Where do you change that?
Well, so the two places. First, the volume plot is the way to start to get at that. But under options and rendering, there are some other things here that you can turn on and off, like whether you're anti-aliasing or whether you force things to run on. So by default, VisIT will understand if it's cheaper to ship geometry over and let you render locally than it is to do the rendering on the back end and ship over an image. You can change it to force it to do what you want, and you can also turn on specular highlights here, and then under advanced there are other things, shadows. You can turn those things on. So the combination of those, the lighting and the view, you have controls to all of those things under controls. So there's lighting and view. You can change those things by hand. The combination of those sort of 5 things are how you get really nice looking imagery out of there.
Well, I guess you'll be around for a few more moments if people want to approach you independently. But otherwise, thank you.
Sure.
Really